In this experiment, I will be looking at Newton's second law and how it applies to my model, which is a soup can rolling across a balcony. In order to show this, my soup can was recorded on a cell phone and then analyzed in Tracker to give us our actual position and VIDLE to give us our theoretical positions. Newton's second law is force equals mass times acceleration. If we deconstruct it a little, we eventually find the format final velocity equals initial velocity plus the net force over mass multiplied by the change in time. In this experiment, we are assuming ideal conditions in that there were no net forces acting on the can, which means velocity is constant. Using Tracker, I now have the position data from my soup can. While the position data originally put all the x values going in the negative direction, I rotated the axes so that the data would be positive. By taking the initial velocity and multiplying it by delta t, we can get the theoretical position of the ball over time, which is modeled in this video made with VPython. As you can see, the theoretical and actual positions are very different. This is because there are net forces acting on the object, and when we use both the final and initial velocities in this equation and add it into VIDLE, we get a much more accurate prediction. It's not really possible to know how many forces are acting on the model. All we can know is that if there's a constant velocity, the net forces must be zero.